Hello everyone. In this video, I'll be explaining how to create an AVL search tree. AVL search tree is a special case of a binary search tree in which one additional parameter is there, which is called as the balance factor. So balance factor is nothing but it is found by the difference between the height of the left subtree and the height of the right subtree. A tree is said to be balanced, an AVL tree is said to be balanced if it is having the balance factor 0, 1 or -1. So if it is other than this value 0, 1 and -1, then the tree is said to be unbalanced. So for an unbalanced AVL tree, what we do is to rebalance the tree, we'll be doing certain rotation which is called as AVL rotations. So we have several types of rotations. That is, one is LL rotation, another one is RR rotation, then we have LR rotation and RL rotation. LL rotation is nothing but if we'll be doing, the tree becomes unbalanced when a new node is inserted in the left subtree of the critical node. Nara rotation is done if the tree is unbalanced and we have to rebalance it when a new node is inserted in the right subtree of the critical node. And LR rotation is new node is inserted in the right subtree of the left subtree of the critical node. In that case, if the tree, if it is unbalanced, then we have to rebalance it by doing an LR rotation. So in RL rotation, the new node is inserted in the left subtree of the right subtree of the critical node. So if a new node is added into the left subtree of the right subtree of the critical node, and if the tree becomes unbalanced, then we'll be doing an RL rotation to rebalance it. Let us see an example how we can create a AVL search tree from a given set of data. So we have this values 40, 23, 32, 84, 55, 88, 46, 72, 57, etc. So how we can form this AVL tree from this set of values. So the first value given here is 40. Okay, so 40 is given. So we'll be starting the node with value 40. So the first value is 40. Then what we have to do is, as I already told, this AVL tree is a special case of a binary search tree. So this will be following the binary search tree property. So binary search tree is tree property is that all the left side nodes will be having value lesser than the parent node, and right side node will be having values greater than the parent node or the root node. So here 40, we'll be starting with 40. The next value is 23. So we have to compare this 23 with this 40. So when you compare this 23, we know that 23 is less than 40. So it should be on to the left side. So we'll be creating a node onto the left side. So you can see it here, this one. So here now when you insert a node, first thing we have to do is we have to check the balance factor. If it is not balanced, we have to do the certain rotations, whichever applicable. So now how will you find this height of the tree? The balance factor is the height of the left subtree minus height of the right subtree. In this case, this 23 here, we can see that 23 is at level 0. So 0 minus 0 will be getting the balance factor as 0. And here in this case, we know left side height is 1 and right side is 0. So we'll be getting 1 minus 0 as the balance factor. So here it will be 1. So in the first step, we'll be getting this one. Now, the second value which we need to insert is 32. So 32, when you want to insert it, we will be starting from the root node. So 40 we are comparing with this 32. So 32 we know it is less than 40. So we have to take the left subtree. So when we are taking the left subtree here, so we are reaching to the point, this node 23. So when you compare this 23 with this 32, we know 32 is greater than 23, so we have to add it to the right side of that one. So 32 will be adding to the right side of this 23. So right subtree we are adding 32. Now we can see, now we'll be finding the balance factor here. Now at 32 it is left side height is 0, right side height is 0, so it is 0. So it is a leaf node. And 23 we know that left side it is 0, nothing is there, so it is 0, and right side it is 1 here. This one is right side tree. Okay, so this level is 1 and right side it is at left side it is 0. So 0 minus 1 will be getting the balance factor is -1. Then when you come to the root node here, you'll be checking the height on the left side. So height on the left side here, you can see that 1 2. So 2 is the height on left side, and right side nothing is there. So 2 minus 0, you will be getting 2 minus 0, the height is, the balance factor is 2. So here you can see that 0, 1, minus 1 and 2. So as I already said that if the balance factor is 2, then the tree is in unbalanced condition. So when the tree became unbalanced, you have to check when we added a node onto the right side of this tree. So when we have added this one, you can see here the first one in the left side, it is here, it is left, okay, for 40, left subtree it is 23, and on to the right of that we have added this 32. That means we have added a new node onto the right subtree of the left subtree. So here we need to do an LR rotation. So when you want to do the LR rotation, so as you know, R rotation will be performed first and then will be left rotation. So when you have to do a right rotation first and then a left rotation. So when you want to do it, is critical node is here, it is 40, that is with value 2, this one. So we have to rotate it, the node just below the critical node. So we'll be doing a right rotation first. Right rotation means it is in the anti-clockwise direction. So we'll be doing an anti-clockwise rotation here at this below this node 40. So when you do this right rotation, we'll be getting this one, it will be like this. So 40 you have, then you are doing a right rotation, so we'll be getting that 32 here, and that 23 will be coming down. So we'll be getting it will be like this. So here it is 0, then it is 1, and here it is 2. So now this is only in the LR rotation. First we'll be doing a right rotation, then we'll be doing a left rotation. Now we have to do a left rotation here. Left rotation means in the clockwise direction. So here we'll be doing a left rotation. So when you do a left rotation at this with reference to this node 32, so we'll be getting the tree like this, 20, 32, then 23 and 40 will come down. So this is what we get after the LR rotation. So this one is after LR rotation. So we'll be getting the tree like this. So here on left side balance factor, if you find 23, it is 0 minus 0, and 40 it is 0 minus 0, 32 is height of left side is 1 and height of right side is 1. So 1 minus 1 is 0. So balance factor, we got it as 0 here. Now the next value which we need to add is 84. Here you can, this much we have done, next is 84. So we'll be starting from here, you just see this tree 32, 23, 40. So when first we'll be comparing with this root node. So 84 we need to add. So 84 is greater than 32. So we know that we have to take the right subtree. So when you are taking the right subtree, you will be reaching the node 40. So then this 40 will be comparing with 84. So 84 is greater than this 40. So again you have to go to the right side of this right subtree of this 40. So we'll be adding that 84 node to the right subtree of this 40. So we have added 84 here. Now you have to find the balance factor. So whenever you are inserting a new node, you have to find the balance factor. So if it is not 0, 1 or minus 1, then you have to do the respective rotations. Now here 23, this node, we know that it is a leaf node. Leaf nodes will be always at 0. Balance factor will be 0. Then here for 32 node, we can see that left side it is at 1 level higher, and right side it is level 2. Height is 2 and left side is 1. So 1 minus 2 will be getting the balance factor as minus 1. Minus 1 here. Then here at 40, you don't have a left height is 0. Then right side height is 1. So 0 minus 1 will be getting the balance factor as minus 1. Now here we know that 0, minus 1 and 0 is only present. That means the tree is balanced. So we don't have to do any rotations here. Now we'll go for the next value which needs to be added. Now 84 is added. Next is 55. So for adding 55, we have to start from here. So 55 we need to add. So 55 will be comparing with 32. We know that 55 is greater than 32. So we have to take the right subtree. So when you reach here, it is 40. Then 55 is greater than 40. Again, we have to take this subtree, the right subtree. Then you will be reaching here 84. So 55, when you compare with 84, you know that it is lesser than 84. So it needs to be added to the left subtree of this node 84. So we have added 55 here. See here we have added 55 to the left side of this 84 node. Now we'll check for the balance factor. So this leaf nodes, the bottommost nodes, that one balance factor will be 0. Here it is 0. Then for 32, this node, left side is height is 1 and right side height is 1, 2, 3. So 1 minus 3 will be getting it as minus 2. Then for here 40, you don't have a left subtree. The height of left is 0. Height of right is 2. So 0 minus 2 will be getting it as minus 2. Then 84 when you check, it is here it is left side is 1 and right side is 0. So we'll be getting it as 1. It is not minus 1, it is 1. So 1 minus 0 will be getting it as 1 here. So this is done. Now here you can see that you have the balance factors minus 2 present here. Okay. So that means you have to do a rotation to rebalance this tree. So where you have to do is, first you just see here we have added a new node, that is 55 onto the left subtree of the right subtree. See, this is the right subtree and we have added 55 onto the left side. So when you are adding a new node onto the left subtree of the right subtree, then we have to do a RL rotation. So here we will be doing an RL rotation. So in RL rotation, we'll be doing L rotation first and then R rotation. So here we'll be doing a L rotation. So the critical node here, it is this one 40, because you can see the balance factor here is minus 2. So we have to do a rotation here at this node 84. Okay. So we'll be doing a left rotation first. Left rotation means we have to do a clockwise rotation here. So when you're doing a clockwise rotation here about this 84, so 84 will come down and 54 will go up. So we'll be getting this. It will be like this. So 23, 34, this portion only got changed. See 84 and 55. Now 55 had gone up and 84 has come down. So now the L rotation is done for our RL rotation. Here also now we have to do the right rotation. So about this node. So when you are doing the right notation about this node, we will be getting, so here it is 40, then we have 55 and then we have 84. So here we are going to do a right rotation here. So we'll be getting 55 will be our root, then 40 will be on left side and 84 will be on right side. So that is what we got here, 55, 40, 84. So this portion we have rotated and we got like this. Now we'll be finding the balance factor here. For leaf node it is 0 and here it is like you see left side height is 1 and right side height is 1, 2. So 1 minus 2 will be getting it as minus 1 as the balance factor here for this node. For this node, left side height is 1, right side height is 1. So 1 minus 1 is 0. So here balance factor is 0, 1, 0 and minus 1. So it is already balanced tree. So we don't have to rebalance it. Now the next value which we need to add is here we have added 55. Now we'll be adding 88. Okay. So 88 we'll be adding here. Yeah. So here this is the tree which we have right now. Now we need to add 88. So we'll be comparing it with, first we'll be comparing it with the root value 32. So 88 is more. So we have to take the right side path. Now we'll be comparing with 55. So we know 88 is more than 55. Again we'll be taking the right path. So we'll be reaching this node 84. And when you compare it, 88 is more than this 84. So you have to we have to add it to the right side of this 84. So 88 will be added on to the right side of that one. So we got it like this. 88 we have added to the right side of this subtree, this node 84. Now we'll be checking for the balance factor. So here we can see that when here this one is left side is 1 and the height of right side is 1, 2, 3. So 1 minus 3 you are getting it as minus 2 here. Then this is 0. And this 55 will be getting left side height is 1, right side height is 2. So 1 minus 2 will be getting it as minus 1. Here the left side height is 0, right side height is 1. So 0 minus 1 will be getting it as minus 1. So here also minus 2 is there. So that means the tree is unbalanced. So we have to rebalance it. So when the tree became unbalanced, when we added a node 88. So where we have added this node 88? We have added this node 88 onto the right subtree of the right subtree. So you can see that everything is on the right side. So 88 is added onto the right subtree of the right subtree. So we have to do an RR rotation here. So where we'll be doing RR rotation, we have to do the RR rotation, the node just below the critical node. Critical node means the node which is having a value other than 0, 1 or -1. So here -2, this is our critical node. So we'll be doing the right RR rotation here just below the node 32. So when you do this RR rotation here, what happens is that we are just rotating this one here. So this 32 will come down like this. So 55. Then 32 has come down. Then we have put this 23 there. Then this portion remains the same because right side. So 55, 84, 88 remains the same. But this 40 we can see it is on to the left hand side. So here now we have on to the left hand side we have a node 32. And we have for 32 the left side node we have another subtree node that is 23. So this 40 is actually basically it is on to the right side of this 32, right? So we can add that 40 to the right side of this 32. So we added this 40 onto the right side of 32. So this tree we got it after balancing. Now we check the balance factor here. It is 0 0. For 32, it is left side height is 1, right side height is 1. So 1 minus 1 is 0. For 55, left side height is 1, 2. 2 is the height and right side height is 2. So 2 minus 2, 0. For 84, left side height is 0. Right side height is 1. So 0 minus 1 is minus 1 and 88, 0. So this tree is already balanced. We don't have to do any rebalancing rotations. Now we have to add 46. Now we'll be adding 46 onto this tree. So for adding 46, what we have to do is we have to check here this one 55. Now 46 we need to add. We'll be comparing 46 with this 55. We know 46 is less than 55. So we know that we have to take a left path. So when you come here, you'll be reaching the node 32. So you'll be comparing the value 46. We know 46 is greater than 32. So we need to take the right side, right path. Now we have reached a node with value 40. So we'll be comparing this 46 with this 40. We know 46 is greater than 40. So we have to add it to the right side of this 40. So what we have done, we have added here right side of that 40. Now we are finding the balance factor. Here for leaf node it is 0. This one is 0. And here this one left side is 1 and right side is for node 32. Left side height is 1 and right side height is 2. So 1 minus 2 will be getting it as minus 1. For node 55, left side height is 1, 2, 1, 2, 3 and right side height is 1, 2. So 3 minus 2 we are getting it as 1. And for 84, left side height is 0, right side height is 1. So 0 minus 1 you are getting it as minus 1. And for 88 it is 0. So here we have the balance factors as 0, 1 and minus 1. So the tree is balanced. We don't have to do any more rotations there. Now we have to add few more values. Okay, we have to add value 72. Now we'll see how we can add that 72 into this tree. It is already balanced tree, that one. So here now we have to add 72. So for adding 72, we'll be first comparing it with this root node 55. Okay, so 55 when you compare, the 72 is greater than 55. So we know that we have to take the right side. So 84 you compare with 72. So 72 is less than 84. So we have to add 72 to the left side of 84. So we have added 72 here onto the left side of 84. Now we are checking for the balance factors. Here for node 32, the left side height is 1, right side height is 2. So 1 minus 2 will be getting it as minus 1. So node 55, you have left side height as 2 and right side height also. Left side height is 1, 2, 3. Left side height is 3 and right side height is 2. So we'll be getting 3 minus 2. The balance factor is 1. So 84 you have left side height as 1 and right side height as 1. So 1 minus 1, 0. And 88, 72 and 46 you are getting. It is the leaf node. So you are getting it as, and 40 here left side height is 0 and right side height is 1. So 0 minus 1, you are getting it as minus 1. So this tree is done. Now you can see that the values are present are the balance factors are 0, 1 and minus 1. So we don't have the values like 2 or 3 like that. So that means the tree is balanced. We don't have to do any rotations to rebalance it. Now the last value we have to add is 57. So we'll be doing that one 57 here. Okay. For adding 57, first we'll be comparing that with 55. We know 57 is greater than 55. So we have to take the right path. Then we have come to 84. Then 56 is less than 84. So we have to take the left hand side, left path of this one, 84. Now we have reached node 72. Okay. So 72, now when you compare with 57, 57 is less than 72. So we have to take a left path of 72. So we have to add it on to the left subtree of 72. So we have added 57 here on to the left side of 72. Now we find the balance factors. Okay. So the leaf nodes are having 0 values. Now when you take this node 32, the left side height is 1, right side height is 2. This 1, 2. So 1 minus 2 will be getting the balance factor is minus 1. And when you compare, when you take this node 55, left side height is 1, 2, 3. And right side height is 1, 2, 3. So 3 minus 3, 0. And when you take this node 84, left side height is 2 and right side height is 1. So 2 minus 1 is 1 here. And when you take this node 72, left side height is 1 and right side height is 0. So you'll be getting 1 minus 0, 1 minus 0 is 1. So this is the final AVL tree that we got, and we can see that all the values are 0, 1 and minus 1. That means the tree is balanced. So this tree, this is the AVL tree. This is how you can create an AVL tree from a given set of values. And when you are creating the binary tree, AVL tree, you need to search. You have to add the new node, insert the new node by following the property of binary search tree. And if the tree is unbalanced, unbalanced means the balance factor may not be 0, 1 or minus 1. So if it is any value other than 0, 1 or minus 1, that means that the AVL tree is unbalanced. In that case, you have to do AVL rotation. So it can be LL rotation, it can be RR rotation, LR or RL rotation, depending upon where you have inserted the new node. Okay, this is how you create a balanced AVL tree, search tree. Hope you understood this one. Thanks for watching. Thank you.